Your MCP clients need to stay perfectly in sync with available prompts, but manually refreshing or polling for changes creates unnecessary complexity. We'll see how FastMCP automatically broadcasts real-time notifications whenever prompts are added, enabled, or disabled, keeping all connected clients updated without extra code. The pattern uses just 3 simple operations to trigger these updates, and we'll walk through each one.
@MCP prompt. Def example prompt, SDR. Return hello. Hash these operations trigger notifications. MCP, add prompt, example prompt, hash sends prompts list changed notification. Example prompt disable, hash sends prompts list changed notification. Example prompt enable, hash sends prompts list changed notification.
This demonstrates the observer pattern combined with declarative registration for dynamic system updates. The @MCP prompt decorator creates reusable message templates while automatically subscribing them to a notification system, enabling real-time synchronization between server and clients without manual polling. The pattern works by treating prompt registration and state changes as observable events. When prompts are added, enabled, or disabled, the system broadcasts notifications to all connected clients, maintaining consistency through event-driven architecture rather than explicit refresh calls. This separation of concerns lets developers focus on prompt logic while the framework handles distribution and state management. This approach solves the problem of stale client-side state in distributed systems. It's particularly valuable for interactive applications where prompt availability changes frequently, such as feature-flagged capabilities or time-sensitive templates. The trade-off is slightly higher initial complexity for the automatic synchronization benefit, making it ideal for systems with dynamic content requirements. Let's break it down line by line.
@MCP prompt. Def example prompt, SDR.
The @MCP prompt decorator registers this function as an AI callable prompt template. It transforms the function into a managed prompt that FastMCP tracks, enabling dynamic enable, disable, and notification events when the prompt list changes.
Return hello.
This defines the prompt's return value, a simple string that will be sent to the AI model. The actual content matters less than the pattern. All prompt functions must return a string, which becomes the AI's input.
Hash these operations trigger notifications. MCP, add prompt, example prompt, hash sends prompts list changed notification.
This registers the prompt function with FastMCP's prompt manager. The add prompt operation broadcasts a prompts list changed notification, enabling real-time UI updates when the prompt catalog changes.
Example prompt disable, hash sends prompts list changed notification.
This temporarily disables the prompt from being available to AI calls. The notification system broadcasts this state change to all connected clients, ensuring UI and other components stay synchronized with the prompt registry.
Example prompt enable, hash sends prompts list changed notification.
This re-enables a previously disabled prompt, making it available again for AI calls. Like add prompt and disable, it triggers the prompts list changed notification to keep all clients synchronized with the current prompt state. This maintains consistency across distributed systems where prompt availability changes dynamically. FastMCP prompt notification pattern. The reactive notification system in FastMCP 2 eliminates polling by broadcasting prompt registry changes to clients during active request contexts, creating a live sync between server state and client interfaces. Notifications only fire during MCP request contexts, not during server initialization, which means your client's first prompt list might be stale until the first operation completes. Always design your client handlers to gracefully handle the prompts list changed notification, as this is the single source of truth for prompt availability.
The prompt that never speaks becomes the loudest voice in the system.